Asteroid 2024 YR4, From Threat to Triumph, a deep dive into Earth's recent near miss and the future of planetary defense. Music fades in, building suspense. It started with a whisper from the void. When Asteroid 2024 YR4 was first discovered in late December 2024 by the ATLAS, Asteroid Terrestrial Impact Last Alert System, Observatory in Chile, it seemed to be yet another routine discovery in humanity's ever-vigilant sky-scanning efforts. But that calm was short-lived. Within hours, orbital projections hinted at something chilling, a potential collision course with Earth in December 2032. The odds, initially pegged at about 1.2%, might not sound catastrophic. But in the rarefied world of asteroid threat monitoring, that number was like sirens in the night. This was no idle concern. As additional observations poured in and orbital calculations were refined, the impact probability rose to 2.2% and soon peaked at 3.1%, placing 2024 YR4 on level 3 of the Torino Impact Hazard Scale, a global system used to communicate the risk of asteroid collisions with Earth. This was the highest ranking for a near-Earth object, NEO, since asteroid Apophis, and only one other space rock had ever scored higher. But what does this all mean? Why did the world's top space agencies react with such urgency? And what are the implications for Earth and its future encounters with rogue cosmic bodies? Understanding the threat. What is Asteroid 2024 YR4? Asteroid 2024 YR4 is a near-Earth object estimated to be between 40 and 90 meters in diameter, based on early observations in visible light. This size range places it in the same category as the suspected object behind the Tunguska event in 1908, the mysterious explosion over Siberia that flattened over 60 million trees across 2,000 square kilometers and generated shockwaves felt hundreds of kilometers away. Unlike the Dino killer Chicxulub asteroid, a 10 to 14 kilometer wide behemoth that ushered in a global extinction event 66 million years ago, YR4 would not pose an existential threat to the planet. But a direct impact could nevertheless cause regional devastation, especially if it struck near a populated area or the ocean, triggering potential tsunamis or atmospheric blasts. The stakes were high, not apocalyptic, but certainly alarming. From threat to clarity, refining the orbit. In early 2025, NASA and ESA mobilized their global network of observatories and data specialists, pooling resources through the International Asteroid Warning Network, IAWN. Using powerful telescopes and radar imaging where possible, they worked feverishly to narrow down YR4's orbital parameters. One challenge: at the time of discovery, the asteroid was approaching Earth in a trajectory that made it difficult to observe, even with large, professional telescopes. Still, astronomers pressed on, calculating the object's orbit based on its motion against background stars. Crucially, as more data points came in, the uncertainty window, essentially a cloud of possible future paths, began to shrink. And eventually, one fact became clear: Earth was no longer in the crosshairs. By March 2025, NASA officially downgraded the impact probability to 0, stating confidently that there is no significant potential for this asteroid to impact Earth within the next 100 years. This was more than a sigh of relief. It was a testament to how far planetary defense has come in just the past 2 decades. Why the Moon isn't off the hook. Interestingly, while Earth was declared safe, the Moon's fate remains a bit more uncertain. Simulations suggest there is still a 1.7% chance that 2024 YR4 could strike the Moon in 2032. While a lunar impact poses no risk to life, the Moon has no atmosphere and no known structures or inhabitants. It could have intriguing consequences for lunar science and human infrastructure if future Moon bases are established. A new crater would be carved into the regolith, and high-velocity ejecta could provide a natural experiment in impact dynamics, potentially observable from Earth and lunar orbiters. Eyes in the sky. Enter James Webb. To refine our understanding even further, NASA has tasked the James Webb Space Telescope, JWST, to observe 2024 YR4 in infrared light, an area where Webb excels. Unlike visible light telescopes that can be affected by the asteroid's reflectivity, albedo, infrared readings can more accurately assess the thermal emission of the object, which in turn reveals its true size, shape, and composition. Webb's observations, coupled with radar and spectroscopic data from Earth-based facilities, will allow scientists to build a high-fidelity 3D model of the asteroid, essential for planning any future missions, scientific or defensive. DART and beyond. What if it had been a real threat? Had 2024 YR4 maintained a high impact probability, Earth would have had some options, thanks in part to the successful 2022 DART Double Asteroid Redirection Test mission. In this unprecedented feat of engineering, NASA crashed a small spacecraft into the moonlet Dimorphos, demonstrating for the first time that humanity can alter the trajectory of an asteroid using kinetic impact. Dimorphos, which measured roughly 165 meters in diameter, twice the upper estimate for YR4, was nudged slightly in its orbit, a seemingly small but potentially mission-saving shift if replicated on an actual threat. The DART mission proved that we don't need nuclear weapons or science fiction schemes to defend Earth. With enough warning time, relatively small spacecraft can divert potentially hazardous objects. Multi-messenger possibilities. A meteor shower to remember? Interestingly, some of the debris ejected by DART's impact is now drifting through space and may intersect Earth's orbit in the 2030s, giving rise to a man-made meteor shower, an awe-inspiring display that would mark the first time humanity has deliberately created a cosmic light show. Similarly, if any future deflection of YR4 were ever necessary, it too could produce spaceborne debris with long-term visibility, offering both scientific data and celestial spectacle. Looking ahead, vigilance never sleeps. Despite the current all-clear, YR4 is far from done with its celestial journey. It will return to Earth's neighborhood 7 times between 2036 and 2076, each time being closely monitored. After May 2025, it will drift beyond Earth's visibility, crossing to the far side of the Sun, a region we cannot see from Earth until it reemerges around 2028. Until then, its memory will remain a symbol of just how dynamic, and sometimes unpredictable, our cosmic neighborhood can be. The takeaway: Earth's growing shield. The tale of 2024 YR4 underscores the increasing sophistication of Earth's planetary defense strategy. We now have early warning systems like Atlas and Pan-STARRS, global collaboration through IWN and ESA's Space Situational Awareness (SSA), deflection technologies proven in real missions, public engagement that treats space threats seriously but calmly. In a world often gripped by terrestrial turmoil, it's heartening to know that above us, thousands of experts are quietly watching the skies, ready not only to alert us, but to act, should the heavens ever send a visitor with less than friendly intentions. And, as always, we invite you to stay curious, stay informed, and stay connected. Click that thumbs up, hit subscribe, and join us as we continue to explore and protect our cosmic home.